So একদম শুরুতে in the very beginning, let's see why this subject is needed in your course. That's the first and foremost concept, that why we need to study linear algebra. What is the genesis of this subject? Let's see. Suppose you have two equations like this: x1 plus x2 equals to 2 and x1 minus x2 equals to 0. The solution is just obvious: x1 equals to 1 and x2 equals to 1. The end. That's it. But the problem begins if you have multiple variables as well as multiple equations like this. This solution was very easy, pretty easy, but solving this system as well as these three variables x1, x2, x3 will not that be easy. Okay. The problem depends. The problem becomes more grave, more serious, and more untractable if we have multiple equations like this: a11 x1 plus a12 x2 plus a1n xn equals to b1. Okay, that's your first equation. Then the next equation is a21 x1 plus a22 x2 plus a2n xn equals to b2. It's your second equation. Okay, next a31 x1 plus a32 x2 plus, in this way, a3n xn equals to b3. That's your third equation. In this way, you have your mth equation like this: am1 x1 plus am2 x2 plus amn xn equals to bm. Now it's a grave problem. You have to solve for this in unknown variables x1, x2, xn, and in order to solve you have m equations. Okay, now suppose m is 100 and n is 100. Now just imagine the situation. You have 100 unknown variables x1, x2, x100, and you have unknown equations. You have to solve for this 100 unknown variables based on this 100 equations. Just imagine that you are using a whiteboard to write down this 100 equations. You will just become mad while you are writing all those stuff all together. The representation becomes very, very tedious. You really cannot comprehend what you are doing. So you are completely helpless in a situation. Okay. Just imagine this: 100 unknown with 100 equations. Just use a very large board and just write down all the equations there. The thing will become very, very complicated, right? So what should we do in order to tackle this situation? Linear algebra comes into rescue then. Linear algebra is not a different segment of algebra or mathematics. Linear algebra is a topic which simplifies a very complex structured representation. Like this, it's a very complex structured representation. But using linear algebra, I can write this complex structure in one single line. That's the beauty of this topic. Okay, how? Very simple. This A11, A12, A1n, these are all known values. They are called the known coefficients. Just collect all these coefficients and place it like this. Okay. Now you have n unknown variables x1, x2, xn. So just put them like this. That's your second part gone. Now just take this b1, b2, b3, bm and put up like this. B equals to b1, b2, bm. Now look at this structure. This structure is a rectangular array of numbers. Just imagine it's a rectangle and numbers are placed in the lines of the rectangle. A11, A12, A1n, A21, A22, A2n, M1, M2, Mn. So all the numbers are being ordered in a rectangular array. Okay? This structure is called matrix. It's called the matrix. Okay? What is the order of the matrix? This matrix has clearly m rows. First row, second row, mth row. How many columns it has? It has 1, 2, n. It has n columns and m rows. So this matrix has the order m cross n. Okay? Now, what is this x curl? It is definitely another matrix, but interestingly, this matrix has only one column. So a matrix having only one column is called a vector. So what is the order of the vector? The order is n cross 1. Because this vector has n rows and only one column, so the order of the vector is n cross 1. Okay. So now, this structure is called a vector. Okay. This structure is another vector. It has m rows, 1, 2, m, and only one column. So just m cross 1. Okay. Now, how to represent this pretty complex structure using this matrix and these vectors? That's the first query. I think you all know about matrix multiplication. In your plus 2 level, you all had matrix multiplication.
Muted acho.
So I think in your plus 12 level, you have all learned about matrix multiplication, right? So just multiply A into X curl. That means A11, A12, A1n, A21, A22, A2n. In this way, AM1, AM2, Amen. Okay? Into X curl. Now just multiply. How to multiply? Just take this row and multiply with this column. So A11x1 plus A12x2 plus A1 in xn. So if we multiply, the first row would be A11x1 plus A12x2 plus A1 in xn. Now look at this second row. Multiply this into this. So A21x1 plus A22x2 plus A2xn. Okay? In this way, AM1x1 plus AM2x2 plus AMNXN. Okay? Now, interestingly, this first row is actually what? It's B1. The second row is actually what? It's B2. The mth row is actually what? BM. So just replace the rows by B1, B2, BM. Okay? Now, this is your B curl. So interestingly, X curl equal to B curl, this one single line, this represents the entire system of linear equation. Okay? So this entire system is being represented by just one single line, X curl equal to B curl. That means this completely entire complex structure is just represented in just one line, just using a few different notations. This A is a matrix, this X curl is a vector, this B curl is a vector. So linear algebra is a topic which teaches us how to represent a complex thing in a very, very simpler manner, in just one line. It's a mode of representation. That's it. For this reason, we learn linear algebra. Okay, suppose you have a very complex algorithm with a few lines of code. Now, the conception of linear algebra can summarize your code in one single thing. So it has immense application in computer programming or in machine learning. Also in statistics, there is a topic called multivariate analysis that you will learn in your semester 5 and semester 4. Linear algebra is a key concept in your multivariate analysis class. Okay, as well as this topic is very, very frequent in JAM or ISI, so you have to learn this topic with utmost care. Okay, so our linear algebra journey would start from this chapter, vector. There we would learn a few concepts. The first concept is linear dependence and independence. That's the first topic. Okay. Okay. The next topic is vector space. Then the next topic is basis and spanning set. The next topic is dimensions. And the next topic is orthogonalization. So that's your vector syllabus. Then you have your matrix course. Matrix operation. Okay. Then rank of a matrix. Then a very important topic called system of linear equation. Okay. Then your next topic would be eigenvalues. Then the next topic would be quadratic form. And the final topic would be determinants. So 40 lectures would cover this as a whole, near about. Okay, so we have to design our class accordingly in order to take 40 lectures. But if we can do some of the classes offline, then definitely the number of lectures would reduce. Okay, so just let's plan for offline class. But today I'll just start the very basic introduction of vector. It's a very important thing. So just start a few concept of vector. Let's see. So let's start with a very simple example. Suppose you are walking in a graph paper, in a two-dimensional graph paper. It's a location, origin. So you are standing at the origin, O. Now if I ask you to go to a point called 2, can you reach the place? Suppose you are standing at the origin and I'm asking you to go to a point 2 on that graph paper. Can you reach up the place? What is your answer? Tell me.
Just 2.
Just 2, yes. Just single 2. Can you reach to a specified position on the graph paper?
No.
No. But if I tell, please go to 1, 2, one specified coordinate, can you reach up to that place?
Yes.
Yes. Now, just recall the definition of vector from your 10th standard or 12th standard. What is meant by a vector? Tell me. What is meant by a vector?
Quantity that has magnitude as well as direction.
Exactly. The variable which has magnitude as well as direction is called a vector. Now just relate the concept in this two-dimensional plane. Whenever I'm saying 1, 2, you can locate a position in this graph paper and you can reach up to that place. Like 1, 2, so this place is called 1, 2. You can reach this place 1, 2. But whenever I'm saying just 2, you cannot reach, because just the single point 2 has no direction. It has only a magnitude, but it has no direction. So a single value 2 is called a scalar quantity. Right? It has only a magnitude 2, but it has no direction. But whenever I'm giving 1, 2, then this thing has definitely a magnitude. As well as it has a certain direction. So this 1, 2 is called a vector quantity in a two-dimensional plane. It's a two-dimensional plane. So in a two-dimensional plane, two numbers altogether represents a vector, or 1, 2, this quantity represents a particular point in this plane. So this is a vector because it has a magnitude as well as a certain direction. So just imagine a three-dimensional plane. In a three-dimensional plane, I can move up to a place called 1, 2, 3. Trio coordinate. But I really cannot move up to a position called 1 or 2 or 3, whatever. So a single value, a single constant value is called a scalar quantity. But whenever we are talking about a two-dimensional plane, a paired number represents a location as well as a magnitude. So a paired number is called a vector. So in a three-dimensional plane, a triplet of number would represent a vector. In a fourth-dimensional plane, 4 numbers would represent a vector. So just recall back to this thing. This x-curl is what? This x-curl is a collection of n numbers. So this is a vector in n-dimensional plane. Okay, because this thing has a certain location in the n-dimensional plane and it has a certain magnitude as well. So this x-curl is called a vector. Similar way, b-curl is also another vector quantity. Okay, that's the idea. So the whole class of vector would focus to this fact and multiple more concepts would be developed. So it's a very basic class as well as a change in language. So please do give me feedback